Hello everyone, Mr. Stevens here. Our lesson today is going to introduce the last concept we need to cover in this unit, which is volume. And we're going to start off by looking specifically at prisms. But before we move into that, let's do a quick bit of revision from last class, calculating surface area. And this is going to be a little bit different than the examples we've seen before. What we have here is a cylinder that's cut in half. I'd love for you to pause the video here and have a go at this yourself. And when you come back, I'm going to show you how to do it. Alright, so when we have a surface area question like this, the first thing we always do is make our net. So there's going to be a rectangle, and that is representing the bottom of the shape, looking at it from underneath. And then now there are the ends of the shape, the semicircles that make up both ends. And the last thing we need to account for is the curved surface on top, which is going to just be a long rectangle. Now, we don't know the length of this curved surface here, so I'm going to call it x. But what we do know about it is that this distance from here to here has the same length as the curved line on the semicircle. And we can calculate this because this is the circumference of a circle, or in this case, half of the circumference of a circle. And we know that the circumference of we know the formula for a circumference of a circle. So we can say that x equals a half times pi d, where d is the diameter of the circle, which is 4 centimeters. And this here, pi d, that is the formula for the circumference of a circle. And we're taking half of it because we only have half a circle. So let's fill in our numbers here. And pop these numbers into our calculator. And we end up with the length of x. And we'll round it off to 2 decimal places. 6.28 centimeters. So now what we can do is we can label our shapes and start calculating our areas. Remember, the formulas that we're going to need are the formula for a rectangle and the formula for a circle. So the area of shape 1 is just going to be 6.28 times 8, which is 50.24 centimeters squared. The area of shape 2 is 4 times 8, which is 32. And okay, so what we can do here is we could calculate area 3 and area 4 as a half pi r squared and a half pi r squared. But if you notice here, what we can do is, instead of just calculating a half pi r squared twice, we can imagine that this rectangle is not here and join our two semicircles into one full circle. one full circle with a diameter of 4 centimeters, or a radius of 2 centimeters. So we can avoid doing these two calculations, and we can simply calculate the area of the circle, which is going to be pi r squared, where r is 2 centimeters. Then we pop that into our calculator, and we get 4 . Now finding the surface area is simply a case of adding them all up. A1 plus A2 plus area of the circle plus 32 plus 12.57. Pop it all in your calculator, just so you don't make any mistakes. Centimeters squared. And there we go. That's how we calculate the surface area of this shape. Right, let's move on to volume. Now, before we go into calculating volume, let's make sure we all have in our minds exactly what volume means. And the important thing here is the empty space inside a three-dimensional object. Those are the key sort of terms in that statement. So imagine, say, you have a water bottle. Some of you might have one with you right now. Maybe it has a volume of 1 liter. That means that the empty space inside that water bottle can fit 1 liter in it. And how we calculate that, well, actually, before we move on to calculating it, we need to revisit this units of volume diagram. And you'll remember at the start of this unit, we saw a diagram like this that showed us how to convert between just millimeters, centimeters, meters, and kilometers. And then when we came to area, we had squared units, so we had to remember to square our conversions. Well, now we're dealing with volume. Volume has cubed units, and so we have to remember to cube our unit conversions. Okay, now let's get on to calculating volume. In the simplest case, which is, a rectangular prism, you can simply times the 3 dimensions together. Length times breadth times height. And that will give you the volume. Okay, in cases where we don't have a simple rectangular prism, what we're going to do is something like this. Let's imagine we have a rectangular prism here. I'm going to draw another one. Okay, so what we need to do here to calculate the volume is we need to look for a face that is the same on both sides. What I mean by that is we could choose the front and the back, or we could choose the left side and the right side, or we could choose the top and the bottom. It doesn't matter which side we choose, okay, as long as we choose a side that is the same on both sides of the shape. For example, the top and the bottom. Let's choose the top and the bottom for now. Let me add some dimensions to this. Let's say This is 6 centimeters. This one is 4 centimeters. And it's 2 centimeters high. Okay, so what we're doing here is we're choosing the top and the bottom as our sides that are the same on both sides of the shape. We're going to calculate the area of one of those sides. So, for example, this is going to be the area of the top. We're going to calculate the area of the top, and we're going to times it by the distance in between our two shapes. So we've chosen the top and the bottom. We're calculating the area of the top, which is this area here, and then we're timesing it by the distance in between the top and the bottom. We use h to refer to this distance. So what this is going to look like is the area of the top, 4 times 6, times the area in between, times the distance, sorry, in between the top and bottom, which is 2. And we can pop that into our calculator and it comes out to 48 cubed centimeters. And the reason why this process is important, rather than just doing this one, is because this process can be applied to any shape that has a uniform cross section. That is, any three-dimensional shape that has a side that is the same on both sides of the shape. Okay, this shaded area at the top here and this shaded area here is the same on both ends of the shape. See, this area here has been shaded in the middle of the shape, but you can see that that same shape exists on the top and the bottom. Right, and that's what we're looking for here. We're looking for an area of a side that is the same on the top and the bottom, or the same on the left and the right, or the same on the front and the back. And then h is the distance in between those two sides. So, let's put that into practice. Here we have a rectangular prism. We could just do length times breadth times height, because that would simply be 1 times 1 times 3, which is 3. Or we could do it this way, area times height. So I'm going to choose the top and the bottom as my two sides. We know that the square on the bottom of the shape has dimensions 1 by 1. And then the distance in between the top and bottom faces is 3 centimeters. So you can see we come out with the same answer. And because this shape is divided up into 3 1 centimeter cubes, it makes a lot of intuitive sense that the answer will be 3 cubed centimeters, because we can see a stack here that includes 3 cubed centimeters. Let's move on to something a little bit more complicated. First thing we're going to do is write down our formula, area times height. So now we need a shape. Here it's been shaded for us, this triangle, that's the same on the front and on the back. And we also have here the distance in between them. So that's everything we need. Remember, the formula for an area of a triangle is half base times height. So we can just fill that in here. We need a half base times height times our 6 here. It's a little unfortunate that we have 2 h's in this formula that mean 2 different things. But that's, yeah, it's just kind of an unfortunate reality of convention that this measurement here is referred to as h. I know that could be confusing, but you will see that like that in textbooks, so it's important that you recognize that these h's are different. So now we can fill in the numbers here. Half times the base of the triangle times the height of the triangle times the distance in between our two triangles. And we pop all of this into our calculator and we end up with 36 cube centimeters. So now what you guys are going to do is you're going to have a look just below this video and you'll find a link to an AP lesson that you can go ahead and try and do some of these questions on your own. Thanks guys.